Welcome to Agron Infotech. In this tutorial you will learn how to carry out two-factor factorial analysis for randomized complete block design using MSTAT C. Before I should proceed to show you how to carry out this analysis, I would like to briefly describe this design. Blocking is the standard practice for agricultural experiments. Field is divided into blocks or units to account for any variation in the field. The treatments are then assigned at random in each block. Blocks are assumed to be homogeneous. The number of blocks represents the number of replications. For example, if an experiment consists of two factors, one factor represents sowing methods and comprised of 3 levels. The second factor is seed priming comprised of 4 levels. Then combination of factor levels will be like this. Randomization is also carried out in combination of factor levels using random table. The source of variation for two-factor factorial design will be block or replications, factor A or sowing methods, factor B or seed priming and interaction of factor A with factor B. So let's get started with this example. First you need to arrange data in Excel as shown here in example. Now you need to define variable and import this data in MSTAT C. I shall just quickly do this, and if you want to know how to define variables and import data in MSTAT C, then also watch the earlier tutorial on how to import Excel data in MSTAT C. The link is also provided in the description. Now the data has been imported in MSTAT C. Go to main menu and select factor or press 19 on numeric keypad. To select no for covariance analysis. Select appropriate design. For this example the appropriate design is RCBD 2-factor A. You can press 8 on numeric keypad to select this design. Press enter and here you will see the layout for source of variation as discussed earlier. Replications represents blocks. Factor A will be sowing methods, factor B will be seed priming and AB is interaction term. Choose yes by pressing Y or just press enter. Here you will need to enter variable number, lowest level and then highest level for this variable. In this example replications is the first variable, so enter 1, the lowest level for replication is 1 and highest level is 3. Now you have to enter the same information for the second variable, that is factor A, or in this example it represents sowing methods. Factor A or sowing method is the second variable, so enter 2 and its lowest level is 1 and highest level is 3. Press enter and then provide similar information for factor B or seed priming. Factor B or seed priming is the third variable, so enter 3 and its lowest level is 1 and highest level is 4. Press enter and here just make sure the information added is correct. Press Y to choose yes or just enter if the information shown is correct. Make sure the cases shown here represents the range of data entered. For this example the number of cases represents 36, which you can get by just multiplying levels of replication, factor A and factor B. If the number of cases are correct, choose yes or simply press enter. If it is not correct, then press N to choose no and give the correct case number. Now select all variables except the independent variables. Press enter. It will be asked whether you want to store means at the end of your file or not. Choose yes or simply press enter, as we want to store means to carry out mean comparison test for significant treatments. Now press S or select save output to disk. Name the file with extension .doc to save analysis of variance. Now in the main menu select SEDITE and then select enter or edit. Here below after 36th case number you will see the means are stored for replications, factor A, factor B and interaction. For mean comparison test you need to note the case number for factor A, then number of means it comprised of or factor levels, and number of observations used to calculate each mean for factor A. Do the same for factor B and interaction. Number of observations used to calculate mean can be found easily by this way. For factor A, the number of observations used to calculate mean can be determined by just multiplying the levels of replications with levels of factor B. Similarly for factor B, the number of observations can be calculated by just multiplying the levels of factor A with the levels of replications. For interaction of factor A and B, the number of replications represents the observations used to calculate each mean. Now go to main menu and select range. Choose an appropriate mean comparison test. Here I am choosing LSD test to compare means for significant treatments. Keep disk as source of means because we have already noted case number of means. Now you need to open analysis of variance file that have been saved earlier as doc file. I often mention with F value to highlight the significant, highly significant and non-significant treatments. In this example, the first parameter or third variable, that is plant height, showed non-significant results for factor A, B and interaction. Second parameter or fifth variable showed highly significant effect of factor A and interaction term regarding yield parameter. Third parameter or sixth variable showed highly significant effect of factor A, B and interaction term. Now you need to provide information for significant treatment factors for mean comparison test. Enter case number for factor A, variable number for means from ANOVA file, observations per mean, number of means, error mean square and error degree of freedom. Press enter and then choose save output to disk. Name the file with extension .doc. Similarly do the same for third parameter or variable 6 for factor A. You will need to change the variable number and error mean square values only. Save the results. Now apply test for factor B. Here you need to change the case number representing the starting point for means of factor B. Enter variable number, observations per mean, number of means and error mean squares values. Similarly do the same for next variable. Now enter information for interaction term. That's all. Here are the results obtained for mean comparison test regarding significant treatments for factor A, B and interaction. The easy to copy means with lettering is to place cursor before the value of first mean and give command F8 while holding Ctrl and Shift key. After this command you can easily select the area you want to copy by pressing Shift and arrow keys. Copy these values and paste in Excel sheet. To bring letters close to mean values, give trim command in Excel. I hope this tutorial will be helpful for you. If you have any questions, please feel free to ask. If you like this video, hit the subscribe button and don't forget to press the bell icon to get notified for upcoming videos.